Okay, so chapter 18 and 19 are going to wrap up our unit on quantitative design because we're going to be focusing on how to analyze quantitative data. So this is our visual from last week where we went through the different types of quantitative design that we are covering. Of course, there's many subtypes within each of these that the chapters went into a bit, but one thing that is the same about all of them is that they are all confirmatory, meaning that quantitative design seeks to either confirm or reject hypotheses. And so in order to do so, researchers analyze the data that they collect using statistical analysis. So in chapters 18, it covers descriptive statistics. In chapter 19, it covers inferential statistics. So you do need to know the difference between descriptive statistics and inferential statistics. Descriptive statistics describes the data that you have collected. There's different ways that we'll go into in a moment. And then inferential statistics makes inferences based on the data collected and the hypotheses that are tested, makes inferences about the population that the sample is representing. So let's go into the different components of descriptive statistics. So the first component is central tendency, and the chapter 18 goes into the three main ways that statisticians measure central tendency: mean, or you might think of this as like the average, the median, the middle number, and then the mode, the most frequent count. And so in the chapter, when you're reading, you will see the authors talk about the pros and cons of each. And so the measure of central tendency that the researcher uses will depend on the data that they collected and whether or not it's a normal distribution or skewed. So based on that is how researchers will decide which one is the best way to report. And typically when you are reading a research article, a quantitative research article, you will see measures of central tendency oftentimes used to describe the participants. So maybe they're the mean age of the participant, or if it's involving teachers, the mean number of years of experience. So that's where you should look when you are reading the method section. Look for any descriptive statistics when they are describing their participants. It might be in other places too, like when they talk about the test scores. If there's test scores that are collected, they might give the mean score collected. And we're going to go into that with inferential statistics because oftentimes they are comparing the means of different groups. So this is something that you can be commenting on in your article critique this week, is to talk about any places where the researcher mentioned measures of central tendency. So another descriptive statistic that you will often see in quantitative studies is measures of variability. And this is how far spread apart the data collected are. So if we're thinking about age, the central tendency would be what is like the average age or the age most representative of everybody. And variability is how much it differs from person to person or from test score to test score, whatever piece of data, whatever data set you're looking at, the variability. So the range is the difference between the greatest number and the smallest number. And then when you're thinking about variance, you're going to be thinking about things like standard deviation. And so in the chapter, they talk a little bit about the normal curve and how that is related to how if things are distributed in a normal curve, how each standard deviation reflects what percent of the population. So within that normal curve, for instance, they talk about 95% of the sample should be within 2 standard deviations, or if that metric is a normal curve for the population, 95% of the population will be within 2 standard deviations of the mean. So when you are looking at your research articles, if they give the mean, you should also look for the standard deviation. So if the standard deviation is small, that means that most of the participants or the test scores are close to the mean. If the standard deviation is large, that means that it is far away. So For instance, I just looked at this, our midterm. So the mean score of our midterm was 82%, and the standard deviation was 10%. So within that, you can see that that is about the range that most of the scores vary between about 70% and about 90%. So that is what you can see there. That would be one standard deviation, and then two standard deviations would be 10 less and 10 more. And then relative standing. So this is something that as educators, we are likely pretty familiar with. Really all of these, and descriptive statistics are something that educators and teachers and people in all types of professions are interacting with pretty frequently. So relative standing, you probably know that as percentile rank. So with the MAP assessment, it gives a percentile rank for students. If you're in the 87th percentile, that means that your score is higher than 87% of the other people like you that took that test. And so statisticians can also describe relative standing using a z-score with a z-chart that they have based on that, and then also the correlation between the variables that they are considering. And so here we have all of the relationships with between the data that are collected. So you will see all of these here, and these are very common that you'll see in the articles that you are critiquing. Analysis of variance, ANOVA, analysis of covariance. So analysis of variance, ANOVA, is a measure that you can use when you have one categorical variable and one quantitative variable. So you'll see that quite often in educational studies. And then regression analysis, when you have your correlation and you're able to make some predictions based on the data that you collected and the correlation that you find. So based on your regression, you'll be able to see what one score will relate to. I think in the text they talk about this in terms of GPA and income, or maybe, yeah, I think it's GPA and income. So I wanted to give you an example of descriptive statistics from a study. So this was a study about coaching teachers and looking at the impact of coaching on general education teachers and special education teachers. So here you can see they have sample characteristics. So when they're talking about the sample, that means the teachers that were included in the study, that is the sample. So N is like the number. So you can see that there were 41 in general education and 12 in special education. So you can see the different groups that they were in here, the percentage women, percentage women in the general education group, in the special education group, their age. So this would be a mean that you see here. So a measure of central tendency they used here, and then SD is the standard deviation. So this is a measure of variance to show you how spread out the data is. Here you can see the percentages of race of the participants in the study, and again, years of total experience. So again, here, this is going to be a mean, and they have the standard deviation. Same thing, years in current position, the standard deviation, and the percentage of the sample that has each of these degrees. Then also the grades taught, the class size, the number of students in the class, and the standard deviation here. And then here, the number of students with an IEP in the general education class versus the special education with the special education teachers. So here you can see all of these different descriptive statistics. So you can see here that they put a note, there was no significant differences between groups for any of these demographic variables. So they did look to see, is there a statistically significant difference? And we will talk about that with our inferential statistics. So underneath a table like this is what an APA format looks like for tables. So you'll see if, look at the note at the bottom, but SD does stand for standard deviation, that's standard. And the text also in chapter 18 does give you all of the symbols that you will need to know. And then here they have the different acronyms. So like the classroom strategy coaching, this is the treatment group. So this is the control group and this is the treatment group. So you can compare that here. And so you should be looking for this in your article critique. Did they use descriptive statistics to describe the characteristics of the participants, or even the results of an assessment, if that's included in there, or whatever instrument or measure they're using? And so here is another example. This is from the article that I did for the sample for the article critique about the achievement gap among English language learners. So here, this is a scatter plot. So chapter 18 also talks about the different types of graphs and ways to represent descriptive statistics. So in this scatter plot, you can see they have on the bottom in this study, they considered both the test scores on the state reading assessment and then also on the scholastic reading inventory. And so they wanted to know how those scores relate to each other. And so they created a scatter plot. So for instance, if a student scored, this looks like probably a 370 on the scholastic reading inventory, they have scored a 320 on the state reading assessment. So for each of the participants, they plotted them. And then here you can see the correlation that they found between those. And so here, this is the write-up that that was from this study where they talked about it here, talking about the linear trend, and then also the Pearson R to describe how strong of a correlation is. And they say it's a moderate positive correlation because 0 would be no correlation, 1 would be a perfect correlation, a perfectly positive correlation. So this one is just slightly higher than in the middle. So you can see here, this is the correlation that they found, but there are quite a few that there is like more variability than you would see in a stronger correlation that's closer to 1. Okay, so inferential statistics are what you're going to see in the findings and the results section of your quantitative studies. And so as we know, quantitative studies are confirmatory. They want to either confirm or reject hypotheses. And all quantitative studies are trying to understand the relationship between 2 or more variables. And so the researchers make hypotheses about what those relationships are, and then they use statistics, inferential statistics in particular, to either confirm or reject their hypotheses about the relationship. So here are some of the main concepts from chapter 19 that you're going to see as you read. So the first one is, when you're thinking about hypothesis testing, is the significance or alpha level. So normally 0.05 or 0.05 is the most common significance level that educational researchers use, meaning that they are looking for a p-value that is smaller than 0.05. And so the researcher can set it. Sometimes it's 0.05, sometimes it's 0.05, sometimes it's 0.01, which would be an even stronger significance level. So when you are looking at the p-value, the probability value, the p-value means, so I guess I have something about, okay. So what I didn't include here that you will see in the chapter is the null hypothesis versus the alternative hypothesis. So those are the hypotheses that researchers are testing. So for instance, when the null hypothesis means that the researchers are saying there is no statistically significant difference in the means between the control group and the experimental group, that whatever they're looking for, that there actually is no difference. And then the alternative hypothesis is that there is a statistically significant difference between those groups. So for instance, if you have a study evaluating the effectiveness of a particular intervention, I think I gave one in perusal about writing daily affirmations. So maybe the research question is, what is the impact of fourth grade students writing daily affirmations on their self-esteem. So one classroom, this would be a quasi-experimental design. So one classroom would write daily affirmations. The other classroom would just keep on doing what they're normally doing. And then at the end, each classroom would take a measure to measure their self-esteem. So the null hypothesis would be there is no difference in the self-esteem score for the class that did the affirmations intervention versus the class that did not. And then the alternative hypothesis would be there is a statistically significant difference in terms of self-esteem in the group that wrote the affirmations. And so the inferential statistics will use the scores from use the sample size and the scores that were collected to determine whether or not there is a statistically significant difference. And the p-value will tell you whether or not there is a statistically significant difference. So if the p-value is less than 0.05 and it's found to be significant, that means that the researchers will reject the null hypothesis and accept the alternative hypothesis that there is a statistically significant difference between the group. And what that means, the probability value, is that the probability that the difference observed is there's a very small chance that this could happen just randomly. So it's looking at what's the probability that this difference could happen by chance. And so if your p-value is 0.04, there's a 0.04 that's the probability that this would happen by chance, is instead of there actually being a difference between the group. So in the text, they go through several examples of this and reiterate that point about what the p-value of the probability means. So here's how they state it here. The probability that this result, that the difference that they found in this study would happen by chance. And so researchers often use software, well, almost always actually at this point. Researchers always use a type of software to help them run these inferential statistics. So one common one is SPSS. And if you're interested, this is provided by Georgia State through your fees that you pay to the library. So if you're interested, there are classes about like Quant 1, Quantitative Analysis 1, Quant 2, Quant 3, where they go through details about how to how to determine what test is appropriate, how to carry them out, how to interpret the results. And in the text too, they mentioned that they do go over, well, I'll mention that when I get there. So then the errors, they talk about the errors too. So the errors relate to the null hypothesis and the alternative hypothesis. So type 1 error is like a false positive. So what that means is that you reject the null hypothesis when the null hypothesis is actually true, meaning that you think that there's a statistically significant difference between the two groups, but actually there isn't. And then type 2 is the opposite, a false negative, where you fail to reject the null hypothesis. You say there is no statistically significant difference between their groups, but there actually is one. So this is an overview of hypothesis testing. And then next, the text goes into the different types of test statistical analyses that researchers can use based on the situation to determine whether or not there is a statistically significant difference between the control group and the experimental group. So t-test, if you have quantitative variables, ANOVA, analysis of variance, if you have one categorical variable and one quantitative variable, and then your correlation coefficients and your regression coefficients. And then one of the most common that I think that you're going to see in your article critiques are ANOVAs. I'm going to give you an example of those too. And so ANOVA will tell you, is there a statistically significant difference between the groups? And if you do find that there is one, you do the post hoc testing to find out which of those groups were the ones that were different. So I again have some examples. So this is from the article that I did for the article critique. And if you want to see more in the article critique sample that I did go through, I think I put a couple different annotations about their data analysis and the statistics that they use, because in this example, they did do ANOVA and then also multiple regressions to analyze their data. And then also we looked at the scatter plot to look at the correlation between the two assessments that they looked at. So here you can see the coefficient that they have, the standard error, the t-score, the p-value, and then the F is from the ANOVA. So here you can see when you're looking at data tables like this, you can start by looking at, one thing that I like to do is start by looking at the p-value. So here you can see that they are determining significance as less than 0.05. And so you can see on these measures, they have one p-value that is statistically significant on their multiple regressions analysis. So what this means is that they found that this was the Scholastic Reading Assessment. This was the State Reading Assessment. They found that Black English language learners had a statistically significant difference in their scores. They had the highest scores on this exam, and in this case, it was statistically significant, whereas the others weren't. And they do have like several different hypotheses and research questions here, but this is just for one. So you can see what this will look like in a paper. And then another thing that they talked about in chapter 19 is the confidence interval and the standard error. So this is another example of how you might see this in a research paper. This is from the same article. This one was about the state reading assessment. So you can see that they have the number of students that identify within each racial group as English language learners. And so this is one thing that you can see is that it's certainly not balanced in terms of the number of participants in each racial group. So they had to do several measures to determine the effect size, since there is such a difference in the number of participants in each group. So here you can see their average test score based on racial identity, and then the rank of the score. So just, this is the lowest score. This was the highest score, the second highest, the third highest, and then the confidence interval. So this is the inferential statistics. So based on the data collected and analyzed, this is the interval that they can find, and then the standard error. And so as you can see, the standard error in many cases is related to the number of participants. So since there is such a high number of Latino English language learners as compared to the other racial groups, the confidence interval is able to have a smaller standard error. It's and this is something that's also discussed in chapter 19 about how sample size impacts the p-value in many cases, and then also the confidence interval that you might have, and also the effect size. So the sample is really important for that. Versus you can see with the Asian students, there's 12. It has a larger standard error, which means that the 12 students in the study, the range was larger with them. And so there you can see their confidence interval there. And then white students, there were only 3. And so their confidence interval, their standard error was it was the third highest, which means that those 3 scores were probably a little bit close together than some of the other groups. Okay, so that is an example of how you will see those inferential statistics presented in here. Let me go really quick to the article to show you how they talk about ANOVA. Okay, so I am in the article critique assignment, the optional one. So the first one is an example that I did. So here you can see the title. I know I showed this article a little bit last week too. But so if you're curious on the article critique, you can look here, but I do want to go to the method section just to highlight some of the descriptive and inferential statistics that you are going to see. So here you can see like the statistical procedures or analysis, statistical analysis. So this study, and not all studies are this explicit, but they should talk about their data analysis. So they say they use a one-way analysis of a variance, ANOVA, and then they cited why that's helpful. Test for 2 or more independent variables and multiple levels for the group, the same thing that you'll see in the text. And so here they do talk about the sample sizes not being equal and how they address that. That's why they used their, the measure that they used was the equality of means, just to make sure that that would still work. Then they talked about using the multiple regressions to understand the relationship between the dependent and the independent variable. They talk about using SPSS as their software to analyze the data. And so here are the research questions. And so here they talk about effect size, how they determine that. Effect size is also covered in chapter 19. And then so you can see the effect size that they found was large for this one. So with their findings, they go through each of them. So here's the scatter plot that I showed you. And then this paragraph talks about the analysis of variance for the research question number 1. So you can see the F-score that they have here. The chapter talks about F-score and then their p-value. So, and then they have the group means for each of the groups that to find that statistical significance. So then again, they talk about the p-value that they're looking for. And then here they see another ANOVA that they read. So the ANOVA for the state reading exam did come back statistically significant. However, the ANOVA that they ran for the scholastic reading inventory was not statistically significant. So here you can see this language. The researchers failed to reject the null hypothesis. And this article does a great job explaining what everything means. They said the sample means are equal for all groups. And then here it said the researcher rejected the null hypothesis. That means that sample means for all groups that they are equal. They rejected that, meaning that they acknowledge that the means are not equal based on this. And then here for research questions 3 and 4, that's where they did their regressions to find out the correlation or relationship between the independent variable and the dependent variable. This is that table that we looked at here. And then they did include the F-score too for those ANOVAs as well, even though they're looking at the regressions here. You can see the significance here. And then the ranked scores that they use for the confidence intervals. So they have one for both the state reading assessment and the scholastic reading assessment here. Okay, so this is an overview of how quantitative studies are analyzed and the different statistical strategies and methods that are used to analyze quantitative design. And so what I wanted to mention as we close out that in the text, the authors, they go through what each of these different tests are and when you should use them based on the different types of variables that you are looking for the relationship in between. And then they do give a resource too about where to look for if you have a test that they don't cover in the chapter. So let me show you that. Okay, so at the end of chapter 19, they talk about the different resources that you can use for significance tests that they don't cover in this chapter. So particularly when you're working on your article critique, if you get a statistical analysis that is different from one of the ones consulted in this chapter, you can go to the companion website or even chapter 12 or 14 if it is a analysis of covariance. So I hope this is helpful, and particularly as you do your article critique this week, I think it will really help you to be able to talk about the p-values and the different statistics that the researchers employ to analyze their data.